Thank you very much, Juan Pablo, for accepting our invitation to talk here in AI Math Conference. And you can make your presentation, please.
Thank you. Good afternoon to everyone. My English is not good, but I try to explain the local influence joined to forward search method to diagnose to outlier data in linear regression models. In this example, I try to explain local influence with forward search. I try to set up in the beginning, the linear regression model is considering y equal to x times beta plus epsilon, where y is response vector, x is matrix of covariables, beta is parameter vector, and epsilon is random vector. In that case, I present one example. In this example, we observed one point that is far from the majority of the data, and that is probably an influential outlier or influence of the model fit. And in that case, when exists outlier data, we can use global influence method. For example, DF fits, other DF beta, Cook distance, or another. But Cook in 96 create another method, more general. That method is a local influence method. Consists of evaluating through appropriate measure of influence the robustness of the estimated provided by the model through minor or small perturbation apply to the model or the data, for example, response or covariables. In that case, let's introduce some notation when let L be the logarithm of the likelihood function, and L theta omega the logarithm of the perturbed likelihood function when omega is equal to W1, W2 until WQ is a perturbation vector, and where the theta and theta omega are maximum likelihood estimate of the unperturbed model L, and perturbed model is L theta omega respectively. In that case, we use the differential geometric. A specific topic is normal curvature. The geometric surface formed by the value of the vector is considered alpha is equal to vector perturbed and or plus likelihood displacement. When likelihood displacement is the 2 times the differential, the log likelihood, the unperturbed model minus perturbed model, where when C is normal surface curvature, is defined the second differential likelihood displacement. After some manipulation, we get that expression. When triangle matrix is the second differential log likelihood about the perturbed model respect to parameter and perturbed vector. And the L2 point is the observed information or Hessian matrix. In that case, is inverse observed information. When get the F, can I give the eigenvector of F? After that, can I use 4 perturbation? The first perturbation is the case, specifically weight to log likelihood. The second is perturbation of response, explanatory, and variance or covariance. And the second method is forward search of Atkinson and Gianni. The emphasis of the method is estimate parameters since some data were removed for purpose of estimation. In that case, we estimate in the set of clean data and delete the outlier data or group with outlier data. To more explain, I talk about the brief example when I use just simple model regression. In that case, use only four data to try to explain with simple example in Y is the response vector and X is the covariables matrix and beta is of parameters vector and set up the Z. The first column is the ones and the second is covariable and the third is the response. And the first step in algorithm is try to take one group with two elements and try to do one combinatory four combinatory with 2. In that case is 6 and get 6 group. In the first step, let's imagine that from these 4 data we form group of 2. Then we have a combination of 4 and 2 would be 6 group. We start beginning to feed the model. We have the fitted parameter and then get eigenvector associated with the Huygens eigenvalue of F. And of the same form up to it 6 groups to find out how to take all the data and calculate the median. In here is the median in each group. And finally, choose the group that has minimum median. For example, in that case, if the minimum is 6 group, in that case, we select the last group. The second step in the algorithm, we add just one data. And when add one data, we create with three data group. In that case, we do one combinatory, 4 combinatory with 3. In that case, we would have group of 3. Then we would have a combinatory of 4 in 3. Would be 4 groups. Then we fit the model. We have the fitted parameter. Then we get the eigenvector associated with the Huygens eigenvalue of F. And the same way up the last group to be able to take all the data and calculate the medians in each group to finally to get the minimum median, and we graph for example, in that case, perhaps this group, the third group is select, and we will graph this eigenvector. And the last step, we take all data and again estimate parameter and calculate the eigenvector associated with the Huygens eigenvalue of F. In that case, to join two methods, local influence and forward search. In that case, I will use rat data, the relation between the percentage of the doses in the liver and body weight, liver weight, and the relative doses was observed. This data is in Weisberg 2005. In that case, appear mass data concept or influential mass data. In that concept is influential mass data are atypical data that were not detected by conventional methodologies such as DF fits, DF vitas, Cook distance, or another. That's why, for example, in that case, in case weight or perturbation case weight, in the beginning, the observation tree appear like outlier data. And the last step of algorithm disappear, is not considered outlier data. So that's why it's considered influential max data. The same way in other perturbation, for example, in covariant perturbation, the observation 3 is in the beginning is considered outlier, but in the last step is not considered the outlier. The same way is the response perturbation and variance perturbation. That method is interesting because it's other alternative to analyze or diagnosis outlier data or influential max data. This is the reference. Thank you.
Thank you very much, Juan Pablo. Let's see if we have any question. Questions must be presented by the chat, or you can open microphone and make your question for the presenter. Okay. I think we don't have any questions. Just let Juan Pablo have our gratitude for this presentation. And in the next session, the discussion talk will be held in a Google Meet link that will be sent for all participants. Okay?
Okay.
So, thank you very much.
Thank you.